Okay, so today we're going to be talking about the collision videos post-lab for the momentum unit. Alright, so first off, what is momentum? Momentum is a conserved vector quantity defined by an object's mass multiplied by its velocity. And we use momentum is equal to mass times velocity, and it doesn't have any special units. So the units that we use for momentum are just kilograms times meters over seconds. So that's what we have for the units of momentum. Now, one of the most important things about momentum is that it's a vector, which means that it has both a magnitude and a direction. Very important that we take note of the fact that it also has a direction, unlike energy, which is just a scalar, so energy only has a magnitude. All right, so why add momentum to our model of physics? The reason why we have to talk about momentum is the fact that energy doesn't always do the trick every time. When two objects collide, what happens here is that energy is kind of lost. And I put lost in quotation marks because energy is never really lost, but it's best to say that it's extremely difficult to collect again. So for example, when two cars collide, we have energy that's stored in terms of sound, and we have energy stored as heat from the collision, or thermal energy, and those types of energy, we can't really collect those in an easy way. So in this case, we can't always use energy conservation to solve problems when we have two things colliding into each other. So that's why we have to take a look at momentum when solving collision problems. Alright, so from our lab and our video analysis, we analyzed all these videos and combined them, and we graphed the total final momentum versus the total initial momentum here. And what we should have found was that it created a straight line, and not only was it a straight line, but it also had a slope of 1, or something extremely close to 1. Now, if we were to do the y equals mx plus b for this graph, what we would have found was that the initial momentum is equal to 1 times the final momentum plus 0. The y-intercept there is 0. And what we have here is an equation that when we take out the 0, because plus 0 doesn't do anything, and we take out the 1 because times 1 doesn't do anything to our equation, we have our equation being total initial momentum is equal to the total final momentum. So what we have here is the conservation of momentum equation. And what this says is that when two objects collide, the momentum before the collision, if we take the total of that, has to be equal to the momentum at the end of the collision, the total final momentum. It doesn't matter that it comes out differently. It doesn't matter if the red ball here was traveling right before and now it's traveling left after the collision. It doesn't matter. It's that the sum of the momentum of the two objects before is equal to the sum of the momentum of the two objects after. Alright, so here I'll just do a real quick example. There's another video on my YouTube channel that walks us through more complicated examples, and I actually show you a way to organize your givens and to solve your problem. But here's a real quick example of how this goes down. So here we have a 1 kilogram cue ball traveling with a velocity of 2 meters per second. It hits a stationary 8 ball of the same mass. After the collision, the cue ball is at rest. we want to take a look at the velocity and the momentum of the 8 ball afterwards. So here we can take a look at the cue ball, which has a momentum of mass times velocity. For the cue ball, we have 1 kilogram times 2 meters per second. And we have a momentum of 2 kgs times meters per second. And at the end, it's not traveling, it's at rest, and that makes its momentum 0. If we take a look at the cue ball, or rather the 8 ball, sorry, we have the 8 ball, its momentum is going to be 0 because its velocity is 0. So its initial momentum is 0 simply because it's not traveling. Now, we want to take a look at the momentum of the 8 ball afterwards. Now, for the fact that before the collision, the total momentum is 2 plus 0. So we have 2 kgs times meters per second as the total momentum before the collision. It has to be that the total momentum after the collision, or the total momentum final, also has to be equal to 2 kilograms times meters per second. All right, so since this is the momentum of the cue ball is 0, that leaves us no choice but to say that the momentum of the 8 ball after the collision, it has to be 2 kilograms times meters per second as well. And if you wanted, you could solve for its final velocity as well. It turns out to be 2 meters per second. So we'll talk more about this in class, and I'll see you later.